It's crazy, right? How a single, totally overlooked detail on a piece of everyday rubber can turn a routine commute into an absolute catastrophe. We all interact with our vehicle's tires every single day, yet honestly, most of us treat them like simple balloons filled with air. Well, in today's Explainer, we're unpacking the high-stakes engineering that's hiding right there in plain sight.
So let's talk about a hypothetical driver. We're going to call him Joel. Joel drives a mid-sized family SUV, and it was time for some new rubber. So he heads to the shop, picks out this rugged-looking new tire because it perfectly fit his 17-inch wheel, and hey, more importantly, it fit his budget. He drives away feeling great, completely unaware that he literally just installed a ticking time bomb on his SUV. Why? Because Joel didn't actually buy an SUV tire. He bought a standard passenger car tire that just merely happened to share the same physical dimensions.
We're going to play forensic investigator for a second and zoom in on Joel's tire sidewall to decode this cryptic string of letters and numbers. Because this isn't just some random serial number, okay? It is the absolute blueprint that dictates the limits of your vehicle's safety. Every single millimeter, every layer of steel, and every ounce of carrying capacity is locked right inside this code. Let's break it down piece by piece.
All right, first up, the 225. This means Joel's tire is exactly 225 millimeters wide from one sidewall edge to the other. Now this dictates what we call the contact patch. That's the actual surface area of rubber physically touching the road at any given millisecond. It's the whole reason your car actually grips the asphalt when you have to make a sudden stop. Moving to the next critical dimension, we have the 65. This is the aspect ratio, meaning the sidewall height is exactly 65% of that 225 millimeter width. And this isn't just an aesthetic choice to make the tire look cool. A taller sidewall eats up more bumps for a smoother ride, while a shorter sidewall is going to give you much stiffer, more responsive steering. It is a crucial metric for cornering stability.
Then there's the R. Inside that rubber, it is not hollow. That R stands for radial, which refers to these incredibly complex layers of fabric cords and steel belts. Radial means these internal plies run essentially perpendicular to your direction of travel. This is the modern industry standard, giving the tire immense strength and allowing that tread to stay perfectly flat on the road even when the sidewall flexes. And finally, the 17. This simply indicates that the tire fits a 17-inch metal wheel. And guys, this is exactly where Joel thought his responsibilities ended. He saw 225, 65, 17, saw that it matched his old tire, and just called it a day. But he tragically ignored the vital numbers that come next, the ones that actually support the massive weight of his SUV.
Here is the crucial and honestly mostly ignored metric, the load index. This little 2 or 3-digit number dictates the absolute maximum weight down to the exact kilogram that each tire can safely carry without failing. For example, a load index of 97, that means the tire can support 1,609 pounds. But jump to a 104 and suddenly it can carry 1,984 pounds. If you slap a tire with a low load index onto a heavy SUV, you are structurally overwhelming that tire before you even put your foot on the gas.
Right next to that load index is the speed rating. Now, it looks like a completely random letter, like an H or a V, but it's actually an immense engineering threshold. An H rating, just as an example, proves that the tire has been scientifically verified in indoor lab tests to withstand sustained speeds up to 130 miles per hour without tearing apart from centrifugal force and heat buildup. It is entirely about maximum safe operating conditions. So the physics here simply don't match up. Joel purchased a standard P-metric passenger tire meant for a lightweight family sedan, but as heavy SUV, it actually requires a much stronger extra load or light truck tire to safely support its sheer mass, cargo capacity, and higher center of gravity. I mean, he matched the dimensions perfectly, but he completely mismatched the physics.
And what happens deep inside that rubber is genuinely terrifying. Because Joel's standard tire can't handle the SUV's weight, it compresses way too much against the pavement. This constant, extreme flexing acts exactly like bending a paperclip back and forth. It causes immense heat buildup deep inside the tread area. Over time, that heat literally melts the internal bonds, leading to sudden air loss and a catastrophic structural separation.
Now I know this sounds like theoretical physics, but it's really not. According to the National Highway Traffic Safety Administration, this exact type of overloading, which actually acts identically to severe underinflation, results in hundreds of tragic, entirely avoidable fatalities every single year. A tire can lose half its structural integrity and not even look flat to the naked eye.
If Joel actually hits the highway on this mismatched tire, he faces a terrifying cascade of mechanical failures.
Because the tire is compressing improperly, it alters the overall diameter, which leads to speedometer errors. The compromised footprint severely reduces hydroplaning resistance on wet roads. Take a sharp turn, and that weak sidewall can completely collapse, causing severe oversteer skidding. And at highway speeds, that heat buildup practically guarantees a devastating blowout.
But all of this builds to the ultimate threat. Modifying an SUV's tire specifications fundamentally alters its handling characteristics. Because SUVs naturally have a much higher center of gravity than standard cars, when a weak, incorrectly rated passenger tire collapses under the cornering weight, it can cause the wheel rim to physically catch the pavement, and that massively increases the likelihood of a fatal vehicle rollover.
So, where exactly did Joel go wrong? Well, his fatal mistake was trusting the generic size chart and that alluring price tag instead of confirming the exact engineering requirements of his specific car. A size chart might tell you that 225/65R17 is super common, but it absolutely doesn't tell you if the load index and speed rating can handle your specific family vehicle when it's fully loaded with passengers and cargo.
To avoid Joel's terrifying fate, there is one undisputed rule in the tire industry you need to know. Placard, not sidewall. Always open your driver's side door and check the vehicle's permanent certification placard attached to the door jamb. That sticker is your ultimate blueprint. It tells you the exact factory-required tire size, the proper load capacity, and the exact cold inflation pressure the engineers designed the suspension around. The number molded onto the tire sidewall is just the tire's maximum limit, not what your specific car actually needs to be safe.
Look, the difference between the exact right size and the almost right size is literally a matter of life and death. So, before you drive another mile, I challenge you. Go out to your driveway, open your driver's side door, look at that placard, and then compare it directly to what is currently stamped on your tire sidewalls. Does the load index match? Does the speed rating match? Because if they don't, you might just be riding on borrowed time.